welcome everyone to the Genetics Podcast. I'm really excited to be here today with Professor Sir Rory Collins. He has been the principal investigator and chief executive of the UK Biobank since 2005. If you're not aware of the UK Biobank, it is, as of today, around 500,000 volunteers that were recruited over the past decade. They're between ages 49 and 69 from all across UK when they were recruited. The project is incredibly unique because these individuals have given consent for research use for their anonymized health records, survey results, questionnaire results, for some people, images like brain scans, and in the last decade or so, genotyping and DNA sequencing. So the impact of the UK Biobank has been incredible on epidemiology and genomics. And I think this is in large part due to the very egalitarian, open philosophy of data sharing that the project has. So hopefully we'll be able to get into this today. So thanks so much. I really appreciate you taking the time to join me.
Thanks very much, Patrick. Looking forward to it.
So I wonder if we could just start off by, if you could take us back to the origins of the UK Biobank, how it got started and, those early days in 2005, and especially how the project has unfolded since then in ways that you expected or maybe didn't expect.
Well, I know that in the last kind of decade of the last century, that a number of epidemiologists, particularly in the UK, but also in the US and across Europe, had been arguing for the need to set up some large prospective studies with really detailed information about people and to follow them long term. And the reason why I think that came from the epidemiological community is that we're typically looking at risk factors that are influenced by disease. And so you have the problem that if you study people with disease, the risk factors may have been changed by the disease, and you get reverse causality. That's not a problem for genetics, and certainly not in the early days of genetic research. There was a lot of focus on case control studies, which were very efficient, and of course, developing disease is unlikely to have much effect on genetics. Unless there's some kind of case fatality effect. So I think the idea of these large prospective studies came largely from the epidemiological community. As one of my previous PhD students, John Dinesh, who's now in Cambridge, said, the great thing about genetics for epidemiology is it brings funding.
Yeah, right.
What seems to have happened around the end of the century was the idea among the funders that maybe setting up a big collection of people would be of value for genetic research. And to some extent, that was part of the original problem that UK Biobank faced, because quite rightly, a lot of genetics researchers said, well, you don't need prospective cohorts for genetics. But of course, if you're interested in the interaction between genes, lifestyle, environment, then you do. And so for whatever reason it got through, the Wellcome Trust and the UK Medical Research Council decided to set up a large cohort. And they came across the idea of 500,000 people in largely middle-aged at least, in order that over a reasonable period of time, at least 10 or 20 years, enough people would develop diseases to allow it to have good power. 500,000 people, probably a number plucked out of the air. How much money could you get from the funders? And I'm often asked, why is it 500,000? And I said, there wasn't enough money for $1 million.
For $1 million, yeah.
That's really the truth of the matter, I think. So they decided to fund this. And at around 2005, I was asked to take on the leadership of it, building on the work of a lot of scientists around the UK who had been thinking through what questions to ask, what measurements to make, particularly how to collect biological samples, particularly blood, in a lot of different ways, and to ensure that things that you'd want to assay in the future, the samples were collected in a way that those could be assayed, even if it wasn't feasible at that time to do it on that scale, and to make sure those samples were stored in such a way that they would be stable and accessible. So there was a lot of work in terms of developing automated systems for processing the samples in a very systematic way, storing the samples, in an audited way, and the ability with robotics to then retrieve those samples. And so that's what we did in 2006, 2010 was recruit 500,000 people from across the UK, aged 40 to 69, got consent from them to use all of their data, including linkage, as you mentioned, into their health-related records, to use all of that data for any kind of health-related research, and for it to be used by both academic and commercial researchers, because our view was that not all the smart people are in universities. There are a lot of smart people in companies, and often there's a lot of porosity between those groups collaborating together, and that we wanted to build a resource that would be used by as many people as possible. And the one requirement that the funders had was this was a resource that was being built for everybody to use. And although I'm described as a principal investigator, I've probably done less research on UK Biobank than almost anybody else. My job was to build it, guided by experts in a number of different areas.
You mentioned the involvement of industry. It seems like you've pioneered a very powerful model where basically private industry chips in to fund sometimes new and risky types of data collection, like genome sequencing, both the exomes and whole genomes. And then in after a short period of time, the data becomes publicly available. Was it challenging to get consensus around that idea earlier? Because it makes sense, but I know that there's always pushback when it comes to private industry chipping into any of these public type projects. But it seems to me like it was probably the only way, in the case of the genome sequencing, at least, to get it done.
Look, I think the interesting thing with UK Biobank is, first of all, not having a hypothesis.
Yeah.
So, again, at the beginning, there was a lot of pressure to say, well, what will it be used for? And my answer used to be to say, I don't know.
Yeah.
It's that kind of Kevin Costner, if you build it, they will come. And the key thing was to kind of think what people might want to do, but not go into the detail of quite how it would happen. And so in a way, it was quite low key, just asking participants for their consent for academic and commercial research. To put into the access policy the idea that it would be available in principle on the same basis. It really does depend, incredibly importantly, on the core funding from the Medical Research Council and the Wellcome Trust, now joined by Cancer Research UK and the British Heart Foundation, to provide that core infrastructure. But then, as you mentioned, the opportunity comes for commercial researchers to think, well, how could we help to make this resource more useful for the kind of research we want to do? And it's been quite interesting how the whole use of the resource and then its enhancement has evolved. So initially, it was pretty much largely, not wholly, used by UK researchers. When the Medical Research Council found some money down the back of the sofa to fund the genotyping, and we had genetic data, and I remember we went to the American Society for Human Genetics and said, look, we've got genotyping on 500,000 people. And people were going, you have what?
Wait a second. Yeah.
We suddenly saw this big increase in research use from the US and other countries. And I then got a call from somebody from Regeneron, Arisparis, who said, you've got this resource. I mean, can we get access to it? And I said, yeah, it's available to academic and commercial researchers on the same basis. And he said, yeah, but can I really get access to it? And so one of the big obstacles has actually been persuading people that it really is available.
Right. There's no tricks. Yeah.
And so Aris put in an application. We helped him to put it in, I think expecting no, and got a yes. And so he, Regeneron, along with GSK, formed a small consortium to fund the first 50,000 exomes. I think they got some really interesting things out of that. And that consortium was extended to maybe half a dozen companies that have exome sequenced all 500,000, or nearly completed that. And those data are starting to be released. And I think that then stimulated other companies to realize this was possible. So as you mentioned, we now have this second consortium between the UK government and the Wellcome Trust, along with 4 pharma companies that are funding the whole genome sequencing, and they have commissioned the Sanger and Decode to do that whole genome sequencing. I think we did a first 50,000 at Sanger. They've now completed another 150,000. So 200,000 of the participants have been whole genome sequenced. Those data will be linked to all the other data, probably around September, October. That consortium will have first access to it, but then 9 months later, those sequence data will be made available to all researchers. So yeah, I think the core is really important from MRC, Wellcome Trust, and the other charities. But then there is this opportunity to leverage additional funding for enhancements. And I think that will work in other areas. As you mentioned at the beginning, we're halfway through imaging 100,000 of the participants. We're hoping to resume quite soon after things settle down from COVID-19. But we think there's a possibility also then leveraging both government and industry funding to do repeat imaging in the UK Biobank participants, because obviously trajectories, changes in, say, brain image measures over time may be both very, very interesting outcomes related to genetics at the beginning, but also very interesting predictors of subsequent cognitive decline. So I think change is somewhere where we can see opportunities for enhancing the characterization of the participants.
Yeah, I think there was a recent paper with something like 50,000 MRI scans, genetic tests, and linkages to cognitive decline. That feels like an area where we're just getting started, and there's going to be an incredible amount of new work.
But it was interesting with the imaging that when we went to the funders, well, actually, with the imaging, we had a working group, enhancement working group. And at one of the meetings, we said, well, what else could we do? And we thought, well, imaging would be good. And there was a crowd of epidemiologists around the table, knowing nothing about imaging. And they said, well, how many people will we need to image? Well, it needs to be quite a lot. We need a really large subset because, of course, again, only a small proportion will develop any one disease. And so we thought, well, could we do 100,000? And then we wrote to a lot of imaging people and we said, well, we're thinking about imaging 100,000 people in UK Biobank. What do you think? And they said, well, imaging is really, really important. You should definitely do that. But you did need 10,000. There's an error, isn't there? And they said, no, we really meant 100,000. And it took about 4 or 5 years for them to understand why that was necessary and why it was then going to be necessary to really optimize the imaging such that it could be done in a short enough time that we would be able to do that with a reasonable budget. And then they have engaged really extraordinarily in making that happen. But when we went to the funders, they said, well, you're going to have all this imaging data. How are people going to make sense of it? And again, it's like any data. Once people have got it, they will make sense of it. So with the brain imaging, people have developed automated methods for analyzing the brain images and pulling out measures that no one knows whether they're relevant or not. And you let the data tell you what's relevant. We're starting to see more and more automated approaches to cardiac images, to body images, to liver. So I think the data, as with genetics, the data are driving methods for pulling out information once you create it at the right scale.
Yeah, it's I forget the exact quote, but wasn't the Sidney Brenner quote that you need new technology, data, and hypotheses in that order? It's something like that, right?
It sounds like Sidney Brenner.
I think he was a fan of the hypothesis-free approach, and it sounds like that was the approach you took from the beginning. But I am still interested in, after 15 years or so, what are the things that have either surprised or excited or interested you the most that have come out of the project?
When we had to go back for our renewal for UK Biobank 3 years ago or so, I was asked, what had UK Biobank produced that it had been set up to produce? And my answer was nothing, because it's a prospective cohort. And the last 10 years or so have been about building it. So I really feel that it will be the next 5 to 10 years when it starts to deliver the really major findings for which it was set up. Having said that, I think the the things I've found really interesting have been how you do things at scale, has been from a kind of practical perspective, has been really interesting. I think the value of creating a lot of data and then putting it out there and letting people's different imaginations work on it. And again, the one thing I would really like to do over the next few years is to increase the numbers of imaginations that are applying themselves to the data. We know it's being used a lot in the UK, in parts of Europe, in North America, but there are a lot of other places in the world with equally imaginative scientists that maybe don't have the resources, the facilities we luxuriate in. And so one of the really nice parts of the whole genome project is that we've been funded as part of that to solve the problem of the scale of the whole genome sequence data. We've been funded to get a data analysis platform set up that would allow researchers to work on the sequence data, to go to the data, because it's now too big, or it will be too big, for the approach we've taken up to now, downloading the data to researchers. And I think that that's going to massively democratize access to the resource, because researchers who don't have a big computer all over the world will be able to go to the data. And in fact, we announced the outcome of that tender. So DNA Nexus with Amazon are going to support this platform. And as part of it, Amazon are going to provide $500,000 worth of free compute every year for researchers in low and middle income countries and for students. So that, I think, will be a way in which we can get very many more people using it. But the thing I've learned is just how much can be produced by having lots of different minds with lots of different, you could say, points of view, prejudices, approaches applied to the same data. You get quite different things coming out of it.
Yeah, and it sets up a system where the best idea wins, right? It's no longer that the data is a scarce resource, somebody's sitting on it and just continuing to publish once every few years. You really have you reverse the situation where you have as many smart brains pointed at this vast and multifaceted data set as possible. And then the level of creativity is just through the roof, right? I mean, I think the explosion in understanding of polygenic risk scores, for example, that in particular, I can't imagine what that particular part of the field would be like if the UK Biobank didn't exist, because we'd be probably still stuck in case control studies that are in large part, there's a degree of power that's held by the group of people that created that cohort in the first place. But something like this has a potential to, well, it really already has, but as you say, going forward, even more potential to just level the playing field in terms of data access.
Yeah, I mean, the polygenic risk scores is an interesting one, and one where you can imagine it's going to have quite a rapid practical value. So the idea that you can find, 3, 4, 5% of the population that have a risk equivalent to a single gene disorder, be it familial hypercholesterolemia or BRCA1, BRCA2. And I think Peter Donnelly has said if you take 16 diseases, then you can find a quarter of the population that is in the top 3 to 5% for one or more of those diseases. Well, that means that a genotype is going to find a lot of people where you might well be able to do something useful for them. So you're a 30-year-old, but you're equivalent to FH on a polygenic risk score. You think about taking lipid-lowering therapy. If you have equivalent of BRCA1, BRCA2, again, you might be thinking earlier age of screening. And of course, the other extreme, the people who are at the very lowest risk, you might have women who are screened either much later or never for breast cancer. So I can see that being implemented into healthcare quite quickly. The other thing that a lot of this you stumble into, but when we were thinking about the data policy, the data access policy, we thought if we try to police the applications, first of all, we will collapse under the weight of applications, we hope, and we will probably inhibit something from being done just because we're not smart enough to realize how imaginative it is. But instead, we thought, well, The beauty about the open access approach is that if a researcher has access to the data and they publish something based on the data, and other researchers have access to the same data, they can go along and check it. So it is, if you like, the kind of the purest form of peer review. And we had an example, last year where somebody did some genetic study. They thought they'd found something really important. They put it into bioRxiv. Somebody else thought this is really interesting. They had the data. They checked it. They realized that there was a problem in the analysis that had produced this result. They drew that to the attention of the researcher. The researcher actually said, gosh, thanks very much. That's really helpful, and withdrew it. So, it becomes a productive form of peer review in that respect, and also very rapid.
Yeah, it's a rapid self-correcting mechanism, right? Yeah. Rather than years of proxy fighting through writing letters to journals and demanding access to data and that sort of thing. It's I appreciate that. It's a very effective tool, and it seems like other projects have started to follow this model. And I think when you speak to participants, we sometimes get this impression that people want their data. They don't want to share it, but actually I think if people trust the institution and they trust the process and they're asked early on in the process, how would you like your data to be handled? Then, I think the 500,000 people in the UK Biobank are a perfect testament to most people want to see good science being done and they want to see it being shared widely. So I also have a hope that when you do get the participants involved early in the process, that comes to light. And you can't, this sounds funny, but sometimes people use privacy as a sort of shield, but they haven't actually asked the participants, if we could share this in a secure way where it's anonymized, your information's not being put out there, would you like to do it?
Yeah, and with the participants as well, we've had only about 1,000 UK Biobank participants have asked to withdraw, and a large proportion of those was very early on. They joined the study and then they thought, perhaps not. You mentioned the issue about commercial use. And we were very careful when, with the Exome Sequence Project, in informing the participants, not only that it was going forward, but why it was going forward, why it was beneficial, even though companies would get IP out of it, why that was actually in the interests of participants and the public. Because, the reality is drugs are made in pharmaceutical companies. Also, that the data would then be made available for other researchers. And I think I had conversations with one or two participants who wanted to discuss it, but it really had no adverse impact on terms of participants wanting to withdraw from the study. But I think when there are those issues, it's very important to be proactive and explain why you're doing these things.
How has the experience been launching the COVID-19 study? I believe you're starting to involve some family members of people who've had positive tests. One of the amazing things about the response of the research community in this crisis has been how quickly groups like yours have responded. What have you learned from that? I think it's another example of open data and fast peer review. There's been any paper that comes out, somebody dips into the UK Biobank data now to check it, and it's on bioRxiv about 2 days later. What has your experience been with the COVID-19 work?
So the key thing with COVID-19 was we wanted to decide what it was we could do that wouldn't otherwise get done. Just focus on a small number of things. So the first thing was, could we get health outcome data in rapidly and frequently to cover the period? So the first thing was getting the coronavirus testing data in, which we're getting in about a weekly basis, and ensuring that researchers who already registered with UK Biobank and had approved projects could get access to those data very quickly to do COVID-19 research. So we emailed out to all the researchers and said, there's a very simple way of just getting agreement to get these data. Then we've been working to get the death and the hospitalization data into the database on a monthly basis. And we put the death data in last week. We'll be putting the hospital data in next week, which will cover kind of up to about April. And then every month we'll be able to update that. The data we've always been trying to get into UK Biobank is the primary care data. And the problem with the primary care data is it's not held by the National Health Service. It's held by the GPs, the primary care doctors. But it's not held by them so much as controlled by them. It's actually on commercial systems. And there are two companies that are the main systems. So as part of the emergency reaction to the coronavirus crisis, the Secretary of State, so the Minister of Health, instructed them to provide us with the data under emergency powers for COVID-19 research. So we're now, in the next few weeks, we'll be getting the primary care data in. And the primary care data is fantastic because it goes back a long time, but it's also current. So you get a lot of information about people's past medical history, their prescription records, all their investigations. And it goes back about 10 or 15 years, if not longer, before they joined UK Biobank. But it is really up to date by comparison with, say, the death and hospitalization. So it's very comprehensive. And I think when we get those data out during July, that is really going to increase the amount of information we have about more or less severe COVID-19. The second thing we did was we were asked by Jeremy Farrow, the head of the Wellcome Trust, and Patrick Vallance, the government chief scientist, could we actually get UK Biobank participants to provide us with blood samples over a regular period to look at seroprevalence for antibodies showing past infection? And we thought about it. We thought, well, the problem is everybody is over 50. And so we thought, well, what happens if we ask the participants if their adult children or grandchildren would sign up? So we have about 250,000 of the participants with email addresses that we have, and we emailed them. And about 120,000 participants and children and grandchildren who are aged over 18 agreed to take part. That was great because that allowed us to pick out the 20,000 we wanted of younger and older people to give us a really good representative sample across the UK from north to south, rural to urban, different socioeconomic status, different age, and even to oversample for people from ethnic minority groups. So we'd have large enough numbers in a population that we know is having a worse outcome from the coronavirus infection. We were able to select these 20,000. We're now getting samples from them. So they're taking a sample with a finger prick, mailing it to us, and then we're getting it assayed. And we're starting to get data through on that. We'll be doing samples from them every month for at least the next 6 months. So we can see how does the seroprevalence change? How does it change in different populations? How persistent are the antibody levels, et cetera, et cetera.
One of the high-level findings from that, if I remember correctly, is that about 10% of people, estimated 10% of people in the London area presumably had a previous infection and had antibodies to reflect that. Is that right?
Yeah, overall in the population, it's around that we've got so far, the data we've got so far, which is a bit incomplete. It's largely participants rather than the younger individuals, kind of around 5 or 6%. But we do see trends with higher rates from people in London, as you said, about 10%, higher rates in younger people, higher rates in people in ethnic minority groups or lower socioeconomic status. We don't yet have the numbers to know what's driving that. Is that age and location and socioeconomic status? So when we get the 20,000, I think we'll be able to look to see, is it age that's driving it? Is it location that's driving it, or both? But yes, it's higher in London and lowest in Wales.
Right. They're doing a good job in Wales.
Yeah.
Has this given you any, and I'm sure you've had this idea for a long time, but has it given you any ideas of a UK Biobank 2.0, 3.0, where you invite the children, grandchildren? From a genetics perspective, would be amazing. I mean, from an epidemiology perspective, I think it would as well.
Well, I think that there have been some discussions around doing that actually before COVID-19. Matt Hurls in Cambridge,
my PhD supervisor.
Yeah, one of the people who was saying, would this be possible? And in some respects, what we've shown is that in principle, it would be. That the UK Biobank participants are perhaps our best salesmen of the value of being involved. And I think it would be really quite exciting to do that. The one thing you always learn from doing a study is how to do it better next time.
Yeah.
So I think there are a lot of things that we could do that would streamline the process. The ability to do a lot of the questionnaires online before people turn up would allow it to be done much more simply, fast, cost effectively. I don't know whether there are any funders with an appetite for it, but I think it's certainly something that could be done. And the response that we had shows that there might well be interest from the children of participants.
Yeah, I think I was a PhD student in Matt's group, and he said on a few occasions that his I think at least one of his parents is in the UK Biobank. So I think it's a perfect testament of your example of participants being the best referral salespeople. Would probably be a quick way to recruit the next generation.
I'm probably breaching your confidence to say that you and Bernie said that he got an invitation to join the seroprevalence study because one of his parents is in it as well. And he told me he'd signed up.
We won't say if he's in this study or not, or whether he's...
Yeah, I don't know whether he got selected.
Yeah.
I got invited, but I didn't get selected.
Only you and a few people probably have privy to that information. I'm conscious of your time. Maybe just to close out here, I'm wondering, I mean, you said earlier that you think basically the best is yet to come, which is amazing to hear because the UK Biobank has delivered so much over the last 15 years. I'm interested in, for the next 15 years, what you see as the future of the study. And I haven't even got to ask you about some of your work in heart attack and those sorts of things. So maybe we have a part two some other time. But I'm interested in what the future holds. If funders want to fund family members, that's great, but I'm sure you have other ideas as well.
I think now with the sequence data and exome sequence data and genotype, the next step is moving into other omics. So Nightingale Health, which is a spin out from a small university company, is already doing NMR lipidomics in the whole cohort.
Amazing.
And there's some discussions going on about doing a proteomic assay coming from industrial consortium funding, which again, I think would be really valuable in trying to get the link between the gene and the disease, as indeed people like Adam Butterworth have shown from Cambridge, how valuable that kind of information can be. So I think more assays, more omic assays, proteomics, metabolomics in the samples would be really valuable. If we can get hold of the primary care data and then also extend into other healthcare record linkages, I think that in the same way that making available the imaging data has brought in the data analysis expertise to pull out image-derived variables, I think if we're able to provide a much more comprehensive medical history of participants, then the data engineers, if you like, should be able to use that data to pull out health outcomes. And I think there's been some very nice work showing that with, say, proteomic data and health outcome data, you can use the proteomic data to subclassify what you think is a single disease. People have used blood type and various proteome data to subdivide asthmas as an example. So I think that kind of moving from phenotyping the participants to phenotyping their health outcomes using advanced techniques will be really quite exciting.
Amazing. Well, I think it's a great view for the future. It seems like you already 500,000 people is an enormous number. To be able to go into that level of depth is really powerful, right? Increasing the numbers only helps to some extent, but getting that full breadth. I was wondering with the primary care data, you mentioned there's an emergency use for COVID. Is there hope that you can kind of parlay this into use across the whole study, or is this remain to be seen?
Well, I think that's where the research community can really help, because if the availability for COVID-19 research demonstrates just how valuable it is, then of course that makes the argument for us that the participants' consent to making it available should be honored.
Right. Why shouldn't it be for heart attack and cancer and so many of these other things that play a large toll? Great. No, I think that's a call to arms to some extent. We can continue to put the pressure on. I just want to say thank you for taking the time. I've learned a ton, and I'm excited to see the next decade of amazing work out of the UK Biobank.
Thanks very much, Patrick.